There's been a lot of focus on Cardano's network speed recently, with the launch of the hugely popular Sunday swap DEX, and people waiting for days to get a chance to buy Sunday tokens. If you follow me on Twitter, you'll have seen my humorous postings on this. Now, I should add, the multiple days delay is specifically for the Sunday token. Transactions for the other pools have been going through in a much shorter time frame. However, it's still not a good look when compared to other blockchains. Thankfully, the plan for Cardano has always been to get smart contract capability launched first, then focus on scaling up. IOG has outlined its plan for scaling up in its January blog post. So in this video, I'm going to go through what IOG is doing to improve transaction speed this year and take a speculative guess at how the end result might stack up against other blockchains. But before I begin, let me set the stage with explaining some basic jargon and concepts. Layer 1s versus Layer 2s. Blockchains can offload their work to other chains. These chains are referred to by various names such as sidechains, subnets, L2s and parachains. It doesn't matter what fancy name you want to give it, it's essentially another chain that you're offloading to because the main chain couldn't handle it. Almost all blockchains need to do this in order to achieve their long-term goals of a very high TPS. These additional chains only vary in how they connect back to the parent chain and whether they still maintain the security level of the parent chain. For this analysis, however, I want to look specifically at the TPS of the parent chain, aka L1. Simple versus complex transactions. When it comes to transactions on a blockchain, they are not all equal. Transactions to simply move value from one account to another is simple and much easier to process. Transactions that require a smart contract to be run require more computational resources and therefore take longer to execute. When comparing TPS across blockchains, therefore, it's important to make this distinction. I will be specifically focused on complex/smart contract transactions in this analysis, as this is where most DeFi users will feel an impact. That's not to shy away from the hundreds of thousands TPS claims that you'll see being flaunted by other chains. Hydra, Cardano's scalability solution for simple transactions, should knock that out of the park, so I'm not too concerned on that front. Bundling. Due to its EUTXO model, Cardano has the ability to group together multiple transactions into a single transaction, whereas most of the blockchains queue up each transaction separately. As you'll see, this plays an important role in estimating TPS. Minimum hardware requirements. It's much easier to make a blockchain run fast if you stipulate that each node must be a high-spec machine. For this reason, I'm ruling out Solana out of this analysis. Its minimum hardware requirement is a CPU of 12 cores and 128 GB of RAM. Avalanche, Algorand and Cardano, on the other hand, all have broadly similar requirements. Now, if you think that's unfair, the argument is Avalanche, Algorand and Cardano could all substantially increase their TPS if they whacked up their hardware requirements, and therefore it's just not a like-for-like comparison. Now let's look at some benchmarks. I'm going to start with Avalanche due to its clear-cut distinction of simple versus complex TPS. Avalanche has multiple chains or subnets built into the core of its design. The X chain is for simple transactions and the C chain is for the more complex smart contract transactions running, for better or worse, on a copy of the Ethereum virtual machine or EVM. The Reddit post shown and the reply to it makes this a little clearer. The post reads, "Where is the 4,500 TPS that Avalanche promises? On the main Avalanche promotional page, there is a table that claims Avalanche can do 4,500 transactions per second compared to the 7 of Bitcoin. However, when looking at the stats on Snowtrace, we see that the network is currently doing 7.7 TPS and there are 500 pending transactions. Is the 4,500 TPS a future promise that has not yet been developed? If it already exists, then are there any stats or charts that show the 4,500 TPS actually achieved in practice? As it stands now, I'm somewhat confused because it seems to be just as fast as Bitcoin. quite a disgruntled Redditor there. The reply reads, if you actually read the docs, it's 4,500 TPS for each subnet for X-chain-like transactions. The EVM is on C-chain, and they mentioned over a year ago it would definitely be slower. I recall low hundreds of TPS without using any layer 2 add-ons. That's easily 10 to 20x of Ethereum's current state. The post goes on to say, that said, they have not yet implemented the necessary changes to allow for these hundreds of TPS so as to prevent spam attacks. If the fees are too low, spammers can waste storage and processing on the network without repercussions. They are in the process of working on a significant pruning solution that will deal with the spam attacks, and then gas fees will be drastically reduced and TPS increased. So Avalanche has plans to scale up its computational chain to a TPS of hundreds of thousands once it figures out how. But to be fair to Avalanche, even without this upgrade, its C-chain has been steadily increasing in TPS since this post was written. Right now, it's doing about 1 million transactions per day, which, if you do the maths, comes to 11.6 transactions per second, which is more or less in line with Ethereum. When it comes to Algorand, I must say I really enjoyed learning about it. So much so, I even watched a 1 hour 20-minute video on Algorand smart contracts. The gist of my research is summed up in my Reddit post below. Essentially what I'm asking is, if you read through the Algorand blog post of August 2020, they promise a smart contract TPS of about 1,000 on the main chain, and then much higher TPS coming through a level 2 solution later in 2021. However, it's now January 2022, and when I take a look at Algo Explorer, the TPS that I'm seeing on Algorand is in the mid-20s at around 25 TPS. So is the 1000 TPS on the main chain actually going to come, or is that going to be through the level 2 upgrade at some point down the line? Bearing in mind what I said at the start of this analysis, that I'm not including layer 2s in my analysis. I also asked about bundling, whether a single Algorand transaction could theoretically hold multiple transactions. Now the response I got back said that the TPS shown on Algo Explorer indicates the average usage of the Algorand network over the last 24 hours, and the 1000 TPS mentioned in the article refers to the maximum TPS that Algorand can process. So theoretically, if the network gets very busy for a long period of time, that number on Algo Explorer could go up to 1000. Now, we can see from the chart that although they haven't had to reach 1000 TPS yet, they have in the past reached around 75 TPS, which is still significantly higher than Ethereum and AVAX. Now, this number that I'm looking at, however, is including simple transactions. So there's no distinction between what's simple and complex transactions. So at this stage, I'm just going to have to take a guess as to what I think would be the complex transactions portion of this. So let's assume total transactions is 25. My complete guess would be maybe that smart contract transactions are around 15 TPS. Possibly lower, possibly it's the same as Ethereum or AVAX. Now, the fact that Algorand actually doesn't use EVM, that's a credible reason why their smart contract execution might be quicker. So let's just give it the benefit of the doubt and say it's somewhere between 15, 16 TPS on your average day, and it can scale up to 1000 if need be. And that upper bound of 1000 comes from this Algorand research article that talks about stateful TIL, which is essentially an Algorand smart contract, and how this approach allows Algorand to handle at layer 1 1000 stateful TIL transactions per second, no matter how large the number of opting in users may be. So that's quite a claim there. We haven't yet seen it in the wild, but if it's true, then that's quite impressive. Which brings us finally onto Cardano. Now, for Cardano, I had to make quite a few estimates, so what you're going to see is highly subjective, but I'm going to walk you through my methodology and my rationale for each assumption. And I'm also going to present to you what I consider to be a pessimistic lower bound scenario and a optimistic upper bound scenario. Okay, so starting with the most recent epoch, which is 317, there were 20,000 blocks produced and 756,000 transactions per block. So if you do the maths, that gives you a very basic TPS of 1.8. I say it's a very basic TPS because A, this combines these simple and complex transactions, so it's an overall TPS rather than specifically looking at smart contracts. And more importantly, it doesn't take into account that within Cardano, one transaction can actually bundle up multiple other transactions. So it's a very sort of crude number. Nevertheless, it's still fairly low because you know that when you take that 1.8 and you look at the smart contract portion of that 1.8, the smart contract TPS is likely to be lower than the 1.8, given that they take longer to run in the first place. So that presented me with a problem of how do I estimate what is the smart contract TPS rather than this very basic TPS. So for that, I refer to the most recent Cardano 360 January update, in which we were told that right now there are about 4 Sunday swap scripts running per block. Now, it wasn't made clear if there were other scripts running in addition to those 4. In fact, the way it was phrased, it made it sound like there were essentially 4 scripts per block and everything else was the more simple transactions or NFTs. So it wasn't entirely clear, but my interpretation is right now Cardano can handle about 4 smart contract scripts per block, and we were told that one script can process about 4 transactions in the case of Sunday swap. That's quite important to stress. But I'm using that as my sort of pessimistic number. For other smart contracts like drip drops, for example, you could have up to 10 or 20 transactions happening in a single script. So that's important to bear in mind. One block is every 20 seconds. So if you do the maths, that gives you a transactions per second of 0.8. So that's kind of our baseline number. It is pretty low. Cannot deny that. So now we get into guesswork territory. So we know that IOG are planning to do block size increase and memory increases over the next couple of weeks and months. Now, for a block size increase, I imagine that would mean that more scripts can be processed per block. That's why I've gone from 4 scripts per block to 6 scripts per block, and that's just my guess. For memory increase, I would imagine a single script can actually process more transactions. And that's why I've gone from 4 transactions per script to 9 transactions. And that figure of 9, I think, is what was actually quoted in the last Cardano 360 update. What I wasn't clear about when that number was quoted, it made it sound like that was the end result of doing both block size and memory increase. But in my mind, a memory increase would impact that middle number, and a block size increase should increase the top number. So I decided to increase the top number by 2. So it's gone from 4 scripts to 6. And for the middle number, I decided to use a number that was quoted in the January update. So it's gone from 4 transactions to 9 transactions. So that's my rationale there. The end result of all of that is that the transaction per second goes from 0.8 that we just saw to 2.7. So a marginally better improvement, but still fairly low. So now we're getting into some really interesting territory. The pipelining improvement is a significant upgrade that's due to take place. There was a blog post on it that talked about the fact that after doing the pipelining sort of efficiency improvement, you'd be able to whack up the block size, the memory usage, and the CPU usage. So based on that, I've had to take a guess. I've gone from 6 scripts per block to 10 scripts per block, from 9 transactions in a script to 15 transactions in a script. And I've left one block every 20 seconds the same, as I think that's more of a fundamental feature. So those were the changes I made. It might be I'm being too conservative here, but this is my more pessimistic scenario. And that gave me a transaction per second of 7.5. So that's quite a nice hefty improvement there. Okay, now we're talking. Now we have a transaction per second of 15. How did I do that? Well, that's through the magic of input endorsers. Big caveat, I have no real idea what input endorsers are. I understand that they pre-prepare blocks so that more blocks can be processed. That's kind of my rough idea. So in between the heartbeat, as Charles likes to call them, you have this empty space. Within that empty space, we can now actually get all the blocks prepared, and then they can be executed. So my guess, complete and utter guess, is that that would impact the bottom metric of how many seconds each block takes to process. And I've gone from one block is every 20 seconds to one block every 10 seconds. I have no idea at all whether that's the right sort of guess. Perhaps it impacts the top number rather than that bottom number, but I've gone for that. So based on that and all the other changes, I've got 15 transactions per second. That puts us above the current Avalanche transaction per second on their C chain, which is their smart contract chain, of around 12. Though, as I said in that chart, they do seem to be gradually improving over time. The other interesting thing about input endorsers is, as I was reading through how Algorand works, part of their protocol seemed to be similar to input endorsers. Don't quote me on it, do your own reading, but that's kind of what I took away from a certain segment of their research paper that I read. It seemed to describe a similar sort of principle. And now it's time for the grand reveal. And I must admit, this is the first time I'm seeing the number as well. As I was recording this video, I actually decided to whack up some of the numbers as I thought I was being a bit too pessimistic, particularly around pipelining improvements. And so this is the first time I've seen what the impact of those changes has had on the overall numbers. So my first estimate actually had me at 18 TPS, and now I'm at 30, and I do have a optimistic scenario to go through as well. So I don't know whether to consider this 30 to be a mid-range guess or a pessimistic guess, but it is what it is. So I've had 18, I've had 30, and then I'll come on to the optimistic in just a second. But just to say that SIPs 31 to 33 are pretty fundamental. In fact, let's just skip over and take a look at those SIPs. So SIP 31, Plutus scripts can inspect transaction inputs without needing to spend them. This means that it is not necessary to create UTXOs simply to inspect the information held by an input. So that should free up a lot of space on the blockchain, because scripts aren't creating these really unnecessary transactions just to read a value from a UTXO. SIP 32, datums can be attached directly to outputs instead of datum hashes. This simplifies how datums are used, as a user can see the actual datum rather than having to supply the datum that matches a given hash. That will have two effects. One is it'll speed up the processing of a script, because you've just got one step rather than two steps. But it may potentially also increase the size of the script if in fact, it likely will, I would imagine, because a hash is quite efficient and quite small, whereas if you're attaching the actual datum, it may not be. But all in all, given that you're reducing a step, I would imagine that it does speed things up. And then the big one, script sharing, SIP 33. Plutus script references can be associated with transaction outputs, meaning that they can be recorded on-chain for subsequent reuse. It will not be necessary to supply a copy of the script with each transaction, hugely reducing friction for developers. Reusing scripts in multiple transactions significantly reduces transaction sizes, improving throughput and reducing script execution costs. So this is definitely, it's a no-brainer. This is going to be a huge improvement. You're not having to include the entire code for everything in a single script. So if anybody who's a programmer knows this, you can either have all your code in one single file, or you could reference other files and it will then call upon those other files. So it's a similar concept. Your single script no longer has to cram in every bit of code. You could have pre-prepared code that you've already loaded elsewhere that it calls upon. So that should be a significant improvement. It should mean Plutus script sizes are a lot smaller, so a lot more scripts can be executed per block. So based on that, I decided that the number of scripts that are executed per block is likely going to increase because each script is now smaller, so more scripts can fit in a block. So I went from 10 to 20 scripts per block, and I kept everything else the same. And that's what gets me to what I'm calling the low bound estimate of 30. Although, as I said, I did have an earlier estimate, which was more around 18. Yeah, that's what I have in this current iteration. So I'm going to do the higher optimistic or hopium based estimate next. But if you are enjoying this video, I highly recommend pressing that thumbs up button, you know, the one down below. Yep, just down there. Yep, you can see it. And whilst you're at it, you may want to consider subscribing if you haven't already, and follow me along on Twitter if you want to keep up to date on my daily ramblings. And then time for the big reveal. This is my uppercase estimate. I have a TPS of a mind-boggling 160. And you can see how I differ from my lowercase there. So I'm not going to make you sit through all of my assumptions once again, but effectively I'm just taking a more optimistic view of some of those guesses that I made. In particular, you see the end result of all of that is that one script can now process 40 transactions, which is an important point to make because I started off this whole exercise saying one script processes 4 transactions, but that's really for Sunday swap scripts. We do know there are already smart contracts out there that do process more transactions, so I'm thinking of something like drip drops. So already that assumption of 4 transactions per script might already be a little bit inaccurate, but I'm going by what was sort of said in that 360 video. So yeah, 40 transactions per script might actually be a reasonable thing to expect after all of these changes have gone through. And yeah, a TPS of 160 is definitely for smart contract execution. Remember, the actual TPS overall, if you include simple transactions, will be a lot higher than that, possibly at the legendary sort of 240, 250 mark that has often been quoted for Cardano. But 160 should be more than enough to handle a lot of at least the current level of workload, and certainly it's a lot more than Ethereum can do right now. So yeah, so there's that. Again, this is all pure speculation. I cannot stress that enough. I am definitely not an expert on any of this. So take it all with a pinch of salt. But I thought it would be good to try and do some sort of analysis to give us some sort of idea of what to expect. So in conclusion, let's say the lower bound is 18, the middle bound is 30, and the upper bound is 160 for smart contract TPS. That is kind of my conclusion. As I said earlier, if you like the video, please give you a thumbs up, consider subscribing, and follow me along on Twitter if you want to hear my daily ramblings. Other than that, I hope you all have a great day.